Find the equation of the tangent line at t equals 1 to the graph. The graph or the function is given in the parametric form, right? Because I see the parametric form. At the point 1, tangent, if you translate it from Latin, I think, means kissing. So it kisses the graph at one point, while secant line cuts through. So that's why we give you this one. We need to know where the kiss is happening, the touch. It's like 1 point. Step 1, solution. I will give you steps for the equation of a tangent line. You must know how to find the equation of a tangent line. For calculus 1, it was everywhere. In calculus 2, only here. And in calculus 3, it will be everywhere in 3D. We'll be looking at equation of a tangent line and tangent plane. Because not only line can kiss or touch the graph, the plane can do that too. So it's going to be pretty phenomenal. Steps. I have very good steps for people to learn. Step 1, how to define equation of a tangent line. Step 1, find derivative to find the slope. Find derivative. Let's not write down as y prime anymore. In calculus 1, we were flexible about this, but not anymore. Calculus 2, calculus 3 introduces more variables. So now, which one is that? With respect to t, with respect to y, with respect to x, maybe with respect to g, some kind of other variable. That's why dy over dx. Now, this notation is important because those derivatives will be different. So, find the derivative. Well, the formula, we just practiced it. Dy over dx equals let me write down one more time. Dy with respect to t goes to the numerator, and then dx with respect to t goes to the denominator. Who wants to help me this time? Someone in the middle? Front rows are always talking, so which is good. But like, let's give other people a chance to wake up.
8 over t.
So dy 8 over t, 8 over 9 over t. That's what you said? What is derivative of y with respect to t? Let's see carefully again. We have equation number 1 and equation number 2. Which one we're using first? This one, exactly. 9 minus. Good job. I will put a blue color. 9 minus what? 1 over t. Amazing. Very good. Very good. This is what we do. Derivative of y with respect to t. Change in rise first. Remember, Americans, they're teaching it as run versus rise. Nobody else does that. Run versus rise. Run goes left and right. Rise goes up and down. So we're checking the change in rise first, and then change in run. Change in run will go in green. So what equation do we use for denominator? The first equation. Tell me, someone. 8 plus 1 over t. Agree? So try to concentrate. This is very cool. If we do it right now, you can finish your homework faster. This one, again, don't have to simplify. If you want, you can create common denominator, blah, blah, blah. But to be honest, it's good enough. The goal is not to find derivative for this whole problem. We're looking at equation of a tangent line. For this, we need a slope. Slope is derivative at the given point. Step 2, find the slope. Step 2, find slope. Slope is denoted by m. Nobody knows why. I actually checked Wikipedia. There says nobody knows why we start calling it m. Around the world, it's not the same thing. And somehow, someone started and everyone started doing it. Slope m. Slope m is dy over dx at the point. New notation. You don't have to memorize it now, but in calculus 3, it will be everywhere. A bar t equals 1. That means derivative at 1. Derivative depends on t, and we're going to plug 1 in that derivative. So plug the point, and the point is given with t. T is given, not x and y. So we're going to plug into the derivative 9 minus 1 over 8 plus 1, which is 8 nines. Does it make sense? So that's a slope. This is slope. Slope actually tells you if the graph is increasing, decreasing. So slope is positive, means at this point, at 1, if you're hiking this curve, you're hiking up, so increasing, going up, positive slope. Step 3. So step 1, done. Step 2, step 1, step 2, done. This is kind of one, sometimes people see it as one step. Finding the slope, but to find the slope, you find derivative. Step 3 is completely different. We need a point. Find if it's not given x sub 0, y sub 0. Sometimes we give it to you, sometimes not. If we gave you, find the equation of a tangent line to the curve at 5, 7. Well, that's the one. That's given. But we did not give it to you. We gave it to you as t equals 1. So what should we do then? I need x sub 0 and y sub 0. X sub 0 and y sub 0. How to find these two? Let's go back and stare at this a little bit. What do you think?
Plug in 1 into your x equation and plug in 1 into your y equation.
Do you agree? Let's try to plug 1 into x and y equation. Exactly. So maybe we gave you the point, 15 and 17 or whatever. But if we didn't, we gave you t. Plug t to find that point. So again, t equals 1 corresponds to some kind of x sub 0, y sub 0. So plug the point. It's literally the same step. Plug the point. In the previous step, we plugged the point into derivative. In this step, we plug the point into original equations. Original. So x sub 0 will be 8 times 1 plus natural log of 1. Y sub 0 will be 9 times 1. You don't have to call it y sub 0. It's just professional to do it, so I did it. But you don't have to. They also call it x naught, y naught, or xy initials. Initial values. What is log of 1 again? 0. So you have 8 and 9. This is the system. It means it's happening at the same time. X sub 0 and y sub 0 is 8, 9. We found the initial point, or point of the kiss, point of the touch. Tangent touches the curve at one point. That's the definition of a tangent line. Step 4 is the final step, more or less. Step 4, you build the formula. I like use y minus y sub 0 equals mx minus x sub 0 formula, point slope formula. Some of you like to use y equals mx plus b, plug in, find b, and then write down the formula. Choose any you like. I like this way more, but you choose your own way. It's still correct. If you know how to do it correctly, do it your way. This is the formula. I'll put it in one more box. This is something we learned from school, and it's gonna just hunt you for the rest of your STEM career. Somehow it's everywhere. Because tangent is important in 3D, in 2D, and so on. So we just, now let's do check marks. Let's see if we found everything. And we found it. We took derivative, plugged 1. X sub 0, y sub 0, we just found it, 8 and 9. Everything is ready, we can plug in. Y minus what? 9 equals m, what is m? 8 nines, x minus 8. This is the answer, but we don't like it. We always ask people to rewrite. That's like extra step. You can call step 5, but usually it's just continuation. Rewrite as y equals mx plus b, because then you clearly can see what is your slope m and the shift b. B is a vertical shift. So that gives lots of information. Y equals 8 9x minus 8 times 8, 64 over 9 plus 9. I just moved everything to the right and distributed it. Y equals 8 over 9x. 9 times 9 is 81. 81 minus 64 is 17 over 9. And that is the answer. The equation of a tangent line to the given curve in a parametric form at the given point. What do you think about that? So the curve has the the function has a curve. We fix the point at t equals 1. T, for example, it's time. When time is running, x and y keep changing on the curve. We fixed, say, 1 second. At second 1, we end up to be at 8,9 point. That's the location, right? At that location, we build the tangent line with a slope 8/9 and a shift 17/9. Does that make sense? This is something from your homework. Reviews old material. The moment you introduce new coordinates, we're working now with new coordinates. We used to have Cartesian coordinates, now we're slowly moving to the polar equations while introducing the parameter. The moment you introduce new system, you have to redo everything. Derivative is different, and tangent of line will have different process, and so on. Questions, ideas, suggestions, critics? Not too bad.